Hello everybody, this video is going to cover our 8.6 notes equations of circles. This should be the last video in unit 8, yay! And we're going to be talking about equations of circles, which we haven't really talked about in the entire unit, which is kind of silly, but you know, here we are. Okay, so the standard form of an equation of a circle looks like this. We've got x minus h squared plus y minus k squared, and that's going to equal r squared. So the center of your circle is going to be found at the values of h and k, and then the radius of your circle is going to be your r value, okay? So in order for us to write an equation of a circle, we need to know the radius of our circle and we need to know the center of our circle. Once we know those two things, we just plug them into our formula, okay? So this first example here says write the equation in standard form of a circle. So I need two things. I need my center, which is going to be a coordinate, and then I need my radius, okay? The center, we can just look and see that the center is at 2, -5. To find your radius, you are going to go north, south, east, and west in your picture to find that value, okay? Sometimes your radius is not going to be a nice number. We'll talk about it when we get there, but for this example, if I start from the center and I go up, north, east, south, and west, my radius, no matter what, is going to be 3. So then what I do is I plug in 2 for h, -5 for k, and then my r, which is 3, becomes r squared. So my equation will be x minus 2 squared plus y plus 5 squared equals 9, because that is r squared. If you look inside of your formula, or inside of your standard form equation, okay, you will see that the signs that go along with the values for the center of your circle are going to be opposite of whatever they were when you put them in your coordinate. And that's just because of the formula, right? Like a negative will always stay a negative, but if the negative is in your formula and your value is negative, two negatives make a positive. So that's why that happens, okay? All right, number 2 says, write the standard form equation of a circle with the center at 3, -2, and a radius of square root of 17. So again, I already know my center is at 3, -2, and I know that my radius is the square root of 17. So I'm going to plug this in for h and k. So I have x minus 3 squared plus y plus 2 squared, and that's going to equal the square root of 17 squared, which is just 17. All right, let's take a look at number 3. So I have my center. My center is nice and easy. My center is at -5, 2. And then the last thing that I need is my radius. Now, normally we would go north, east, south, and west. But if you look at this image, we have kind of this unknown value at the very end of our radius, and I'm not going to estimate. I want to know the actual standard form equation. So if you look at this picture here, we were actually given a point on the edge of our circle, this one. Okay, we can use that in our formula to figure out what our radius is. So my center is still going to be h and k, but then this other point, I'm going to plug in for x and y in my equation. So I'm just going to write this down really fast so you can see what I'm doing. Okay, so the x value that I'm going to use is this -8 that I have over here. So we're going to have -8 minus, and then my center is -5, so that's going to become +5 squared. The y value that I'm going to use is this one over here. It's that 4 minus 2. That's my k value, and that's going to equal r squared. So now I have enough information other than my radius, and I can just solve this like a regular equation. -8 plus 5 is -3 squared. This will be 2 squared. That equals r squared. This will be 9 plus 4 equals r squared, 9, 10, 11, 12. So they are, when I work this out, I get that 13 is r squared. Now, at this point, normally when I'm working with equations, I want to square root r squared to find the radius, but remember that our formula is r squared, and I already know what my r squared is, so I'm not going to square root it. I actually don't need to. So now I've got my center, I've got my radius squared, and now I can plug all of this in. Okay, so my final answer is going to be x plus 5 squared plus y minus 2 squared equals 13. And that is going to be my standard form equation of my circle. And I was able to do that because I was given a point on the circle. All right. Number 4, the endpoints of a diameter of a circle are -5, 3, and 11, 7. What is the standard form equation of the circle? Okay, so here we have a circle. We know that the diameter goes through the center, remember. We're going to say that this is -5, 3. This is 11, 7. So I need to figure out what the center of my circle is because I need that for my standard form equation. So the center is in the center, so we can actually use midpoint to find that. And as a reminder, with midpoint, we take our x values and we add them together and divide by 2. And then we take our y values, add those together and divide that by 2. 11, 10, 9, 8, 7, 6. So this is going to be 3, 7, 8, 9, 10, 5. Okay, so my center is at 3, 5, and then I'm going to use this other point on my circle as my x and my y. It doesn't matter which one you use. You could have used -5, 3 as your x and your y, but I'm going to use those other two numbers just because they're a little bit nicer. Okay, so now I'm going to do this. Squiggle. All right, so x minus h squared plus y minus k squared equals r squared, because I still have to find my radius. I don't know that. This will be 8 squared plus 2 squared equals r squared. This is 64 plus 4 equals r squared. And I get 68 equals r squared, and I'm not going to go past that. And then my final answer, final answer will be x minus 3 squared plus y minus 5 squared equals 68. And there we go. All right, this next section says, determine if the given equations define a circle. If the equation defines a circle, then we're going to rewrite the equation in standard form, because if you look, none of these are in standard form. Really, number 1 is probably the closest looking thing to standard form. Okay, it says list the center and the radius. So in order for an equation to define a circle, it has to look like this. X minus h squared plus y minus k squared equals r squared. Okay? Now, if you look at this first example, this side over here definitely looks like it is part of the standard form equation of a circle. But this side over here looks a little bit weird. So what I need to do is I need to make sure that my x squared and my y squared are on the same side of my equation, and that my my constant, okay, my number that doesn't have a variable with it, is on the other side. So what I need to do is I actually need to start by adding x squared over so that it's on the same side with y squared, but I am going to take my entire equation and flip it just so that it looks a little bit nicer. So this is what I have. I have x squared plus y minus 1 squared equals 4. Now the question is, does this represent the standard form equation of a circle? The answer is yes. I know that x looks a little bit funky, but how this is written would be the same thing if I did this. But no one writes a 0 in their formula. So if part of the center of your circle is 0, you just might not have it, and that's okay. So we would say, yeah, this looks great. So let's go ahead and let's list the center of our circle and then the radius of our circle. So the center is going to be 0, 1. That comes from the 0 that would be with this, and then the 1 comes from this part of my formula. And then r squared, remember, is at the end, which means that r is actually going to be 2, not 4. So here we go. That looks wonderful. Beautiful. Easy peasy. Okay, now I'm going to look at number 2. If you look at number 2, x's and y's are on the same side. The value that does not have a variable with it, my constant, is by itself. That's beautiful. We do have an issue, though. I have an x squared and an x, and I can't have that. I need all of the x's together. So this is where we have to do something that you may or may not have learned in Algebra 1, depending on where you came from, okay? And it's called completing the square. And completing the square is essentially where we are trying to create a trinomial that, when factored, gets me 2 of the exact same factors. For example, okay, if I had x squared plus 10x plus 25. When I factor this, I get x plus 5 and x plus 5. When I get that, I can write this as x plus 5 squared. Okay, that is me with a perfect square trinomial. And that's what I want. So when you complete the square, your ultimate goal is to make this c value, because remember that standard form of a quadratic is ax squared plus bx plus c. I want this c value to make it to where I have a perfect square trinomial. And there's a little tiny baby equation that we get to use. It's not really even an equation, it's a little formula that we get to use to ensure that that happens. So I'm going to show you how to do that. In order to make a trinomial with my x's, I don't need to do it with my y's because I already only have one y. What I need to do is I need to create a space for my brand new c value. Okay. Now, because I've added something to the left side of my equation, I must also add the same thing to the right side of my equation. Now, my goal, remember, is to find a number that goes at the back where that blank is, where I'm going to have a trinomial that when I factor, I get the same two parentheses so that I can write it as something squared. And the way that we do that is we take this term right here known as our b value. We do b divided by 2 squared, and whatever we get goes here, and we'll go wee and go way over here. Okay, our b in this case is 6, so we will do 6 divided by 2, which is 3, and then 3 squared is 9. So both of these blanks, a 9 will go. Now that I've done that, this is what I have. I have x squared plus 6x plus 9 plus y squared equals whatever 27 plus 9 is, and that is 36. Okay? At this point, I'm only going to focus on this trinomial. When I factor this, I will get x plus 3 and x plus 3, which was my goal, and I can write that as x plus 3 squared plus y squared equals 36. And now we have a beautiful standard form equation of a circle. So at this step, I need to write down the center, and I need to write down my radius. The center is going to be -3, 0. Remember, the -3 comes from here, and the 0 comes from the fact that there's nothing with y, so it's got to be 0. And then my radius is going to be 6, because that is what the square root of 36 is. Yay. Lastly, we have this example. Again, my x's and my y's are on the same side, which is beautiful, but I've got 2 x's and now I've got 2 y's. So essentially what we have to do is complete the square twice. Here we go. I'm going to put my x's together, so I'm going to move that 4x from the back to the front, and I'm going to put a blank space. And then I'm going to do y squared minus 12y plus a blank space. And that is going to equal 10. I've added 2 blank spaces to the left, so I've got to add 2 blank spaces to the right. And we're going to do the exact same thing we did a second ago, where we do b divided by 2 squared. That's going to go here, and then it's going to go into one of these blanks. And then I'll do that here. We're going to do b divided by 2 squared. That's going to go here, and that's going to go there. Okay, it's always that middle term that you're going to divide by 2 and then square it. 4 divided by 2 is 2. 2 squared is 4. So each of these blanks will be a 4. And then I'm going to come over here, and then -12 divided by 2 is -6. -6 squared is a positive 36. So that's going to go here. Okay. So I've got x squared plus 4x plus 4 plus y squared minus 12y plus 36 equals, let's go ahead and let's add all of that together. 10 plus 4 plus 36 is 50. Okay, I'm going to factor this side, and then I'm going to factor this side. This will be x plus 2 squared. And then over here, we got to be careful because that middle term is negative. Okay. Now, no, I'm not going to do that. Okay, so now we need our center, and we need our radius. Our center is going to be -2, 6, and then our radius is the square root of 50. So I'm going to come over here and actually square root 50. That's 2 and 25. That's 5 and 5. So my radius is 5 root 2. And there we go. All right. Woo! That was a little bit of a doozy, but we did okay. All right, now I'm going to give you an equation of your circle, and what I want you to do is graph it, and then mathematically we are going to find the x and y intercepts of the circle, because we're not going to get a nice x and y intercept, I don't think. Leave answers in exact form. Cool. All right. So graphing the circle, remember that the first thing that I need to do is find my center, and the center is going to come from your h and your k values. So this will be a -3 and a 2. So 1, 2, 3, 1, 2. Now what I need to do is find my radius, and my radius is essentially the square root of 24, which is not a nice number. So we're going to do the square root of 24, and that gets me approximately 4.9, so almost 5. So we're going to go 1, 2, 3, 4, almost 5. I can't go north, which is unfortunate. I probably should have picked a different problem, but that's okay. We're going to go down 1, 2, 3, 4, almost 5. And then here we go. We're going to go this way. We're going to go up. And we're going to go this way. So my circle is kind of off my graph a little bit, but we did a pretty good job. So if you can envision what's happening, my circle exists like over here somewhere. That was a pretty darn good circle, guys. Whoosh. Okay, but now what I need to do is I need to mathematically find my x and my y intercepts, because if you look at your graph, we had to do a lot of estimating to get there. So this is going to be a little bit of a pain in the tush, but I promise it's not that bad, okay? So a long time ago, like back in Unit 2, we talked about how to find x and y intercepts of linear standard form equations. So now what we're going to do is talk about finding x and y intercepts in our circle standard form equations. Now, anytime that you have an x-intercept, just as a reminder, your x-intercept is anywhere that you have a y value of 0, okay? And then our y-intercept is anywhere that you have an x value of 0. So what we're going to do is we're going to take our standard form equation that we have up here, okay, and we are going to plug in 0 for y. So this will be 0 minus 2 squared equals 24. And then whenever we go to do our our y-intercept, that's where x is 0. So this is going to be 0 plus 3 squared plus y minus 2 squared equals 24. All right, let's do our x-intercept first. I'm actually going to leave this alone for now. 0 minus 2 is -2 squared. That's going to equal 24. X plus 3 squared plus 4 equals 24. We're going to go ahead and subtract 4 from both sides. We get x plus 3 squared equals 20. Okay, now that we're here, what we can do is we can actually take the square root of both sides. And that lets me cancel out that square root, and then I got a square root 20. When I do that, okay, we got to think back to Algebra 1 a little bit. When you square root a number, you actually get the positive and the negative of that number. So right now we have the positive and the negative square root of 20. And I'm going to leave this alone for now. I do need to go and simplify that in a minute, but I don't want to do that right now because this is going to be a little bit crazy. So this is what I have. I have x is equal to -3 plus or minus the square root of 20. Now, before I box this as my final answer, I actually need to break down the square root of 20. And I think I'm going to scoot this over so that I have a little bit more space to do this. 20 is 2 and 10, 2 and 5. So this number goes on the outside. So my final answer will be -3 plus or minus 2 root 5. And those are my two different x-intercepts. Remember that one is the plus and one is the minus, which is crazy, okay? They're pretty gnarly. Now I'm going to come over here and find the y-intercepts doing the exact same thing. This is 3 squared plus y minus 2 squared equals 24. This is 9 plus y minus 2 squared equals 24. We're going to subtract 9 on both sides. And we get y minus 2 equals, whatever that is, 24 minus 9 is 15. We're going to square root both sides, so we have y minus 2 equals plus or minus the square root of 15. The 15 doesn't simplify, by the way, because it's 5 and 3, so I know I don't have to go any further with that. I'm going to add 2 to both sides, and we get y is equal to 2 plus or minus the square root of 15, and those right there are your y-intercepts. So that means that we have 2 y-intercepts and 2 x-intercepts, which kind of makes sense, even though we can't see them on this graph. Your x-intercepts are going to be here, and then there would be another one over there, and then your y-intercepts are here, and then there would be another one up here somewhere. So depending on your graph, okay, that's where your intercepts will be. Sometimes you can have 1 x-intercept and no y-intercept. Sometimes you can have 2 y-intercepts and no x-intercepts. You can have 1 of each. It just depends on where your circle is located. You could have none if your circle is really small and up in a quadrant somewhere, okay? But that's how mathematically you would find those intercepts. All right, we're going to move on to one of my favorite parts of circles, and I know that this video is taking a long time, and I apologize, but I promise it's not that bad, okay? This is my favorite page. Okay. The face of a clock is a circle. Whenever you have an analog clock, it looks like this. You've seen it in every one of our classrooms, okay? Because it is a full circle, it can be represented by 360 degrees. So it says, how many degrees are there in 1 hour of time? So I want you to imagine a minute hand, not the hour hand, the minute hand, okay? The minute hand will always start here at 12, and then it's going to go around and around and around and around and around and around and around. And then after an hour, it's back to where it started. So in a clock, an hour of time is actually going to be a full 360-degree rotation of that minute hand. Okay? Now let's think about 30 minutes of time. Well, a clock at 30 minutes is essentially half, right? The minute hand would go until it hits 6. And that would be 30 minutes. Well, that's half of your circle, so this would be 180 degrees. Okay, what about 15 minutes of time? Well, 15 is a quarter move of your minute hand. So that's we're going. Oopsies, I didn't want it to be in pink. We're going, and then we stop here at 3. So how many degrees would that be? Well, that would be 90 degrees. Okay. And then what about in 5 minutes of time? Well, 5 minutes of time is when you go from one number to another. So I stop here. So my minute hand would be there. So they're basically saying, well, how many degrees is that? Well, if the full circle is 360 degrees, but there's 12 numbers on my clock, I can just do 360 divided by 12, and I get that every 5 minutes of time is 30 degrees. And then what about 1 minute of time? Well, 1 minute of time is one of these little tick marks. So a minute of time would mean that this clock is really hard to draw. It would be that amount, okay? Well, how many tick marks are there on your clock? Well, there are 60. So let's do 360 divided by 60, and we get 6. Okay, so each minute is going to be 6 degrees. Okay, the one that is the most important for us in what we're doing right now is the degrees in 5 minutes of time. Okay, so we're going to use that information that we just learned about here, and we're going to draw our clock. It says if a clock is set to 8 p.m., after 30 minutes has passed, what will be the measure of the major arc formed by the hour and the minute hand? Okay, let's talk about a clock for a minute. Here we have a clock. Every time we do a problem like this, I want you to draw a clock. You don't have to draw like all of the tick marks that are in between, but you're going to want to do all of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's the center of my clock. At 8 p.m., that means that my hour hand is at 8 and my minute hand is at 12. Okay? It says after 30 minutes has passed, what will be the measure of the major arc formed by the hour and minute hands? Well, we already know that in 30 minutes time, that minute hand has moved down to 6, right? We already know that. What you might not know, maybe you do, I don't know, is that the hour hand will also move. The hour hand does not go from 8 and then just jump all the way to 9 after an hour, okay? After 30 minutes of time, the hour hand has moved halfway between 8 and 9. Okay, so we no longer have these. Now what we have is this, and it's asking us for the major arc. So the major arc is this. We go wee all the way around our circle to about here. Okay, that's the major arc. Now the easiest way to do this is to count all of the 5-minute intervals, because we already know that those are going to be 30 degrees no matter what. So here is 30, 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 here is 30. This is not 30. We got to figure out what that is, okay? But each one of these are 30. And look, it looks like a little flower with all these 30 degrees, okay? All right, so right now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So right now we have 9 30-degree little jumps, okay? What we need to figure out, though, is how far I have traveled from the hour hand, where I started at 8, to where I am between 8 and 9, okay? The easiest way to do that is this. We're going to set up a proportion, okay? In a clock, there are a total of 60 minutes, and we have traveled 30 minutes, right? Because we started at 8 o'clock, and then we went 30 minutes to 8:30. So in a clock, that's 30 minutes out of 60 minutes. In a circle, we know that a circle has a total of 360 degrees. Well, how far have we traveled? If we're looking at a full circle, how many degrees is that? We can set up a proportion, okay? Part of it will be the clock, and part of it will be just a full circle. So we can do 360 times 30 divided by 60. Wait a minute, something isn't right here. 360 times 30 divided by 60, 180. Why does that not? Oh. Why is this weird to me? I know that it's moved half of 15, but why am I having such a tough time with this? I think I messed this up. I don't think it's supposed to be that. We do set up a proportion, but I think it's how many... Okay. It's 30 out of 60, because that's my clock. But the other side, I think, is between my numbers. So how many degrees is that out of 15 degrees? No, it's how many out of 30 degrees, because we're going 30 degrees. I'm so sorry. I mess this up every single time I teach it. 900 divided by 60 is 15. There we go. Okay. I'm going to try this again. I'm going to explain this again. All right. We have traveled. So in a clock, we've got 60 total minutes, right? We know that we've gone 30 minutes because it tells us that. What we need to do is we're trying to figure out between my 30-degree intervals, those are between my numbers, how far I've traveled, which is why it's got to be over 30, okay? Because that is the distance between the number 8 and the number 9. It's 30 degrees. There we go. That makes more sense. Sorry, that was weird, okay? So X is going to end up being 15, which means that this bit over here is 15 degrees. So I've got to add 15 to that. So we're going to do 9 times 30 plus 15, and that is 285 degrees. I apologize for that confusion. It will not happen again. Let's take a look at number 7. If a clock is set to 2 o'clock p.m. after 50 minutes has passed, what will be the measure of the minor arc formed by the hour and the minute hands? Okay, again, we're going to draw us a circle. It's a clock. We're going to label this clock 12, 3, 6, 9, and then we're going to do all of the numbers in between. Okay. And right now it is set to 2 p.m. So my hour hand is at 2, my minute hand is at 12, and then it says after 50 minutes has passed. So we're going to go. And now my minute hand is at 10. I got that. My minute hand's gone. But then my hour hand, remember, is not quite at 3, but it's definitely not at 2. Okay, it's somewhere in here somewhere. So I'm going to delete my old hour hand and minute hand. And now what I need to do is I need to find the minor arc that goes from here to not quite 3. And I'm going to put a dot at 3 just so we can see that we haven't traveled all of that distance yet. Okay, remember that between each of the numbers are 30 degrees. So I know that I've traveled 30, 30, 30, and 30. I don't know how much I've traveled there. So right now I've got 1, 2, 3, 4. I've got 4 30-degree jumps. So now what I need to do is I need to set up a proportion. Okay, remember that one side is your clock and one side is your degree. A clock is always out of 60 minutes and our degrees are always out of 30 degrees because that's how many degrees are between my numbers and that's what I'm looking for. Now, I have gone for 50 minutes. So I need to put 50 over 60. Okay? So we've got 30 times 50 divided by 60, and that means that I have traveled 25 degrees. So this is 25 degrees. So I've got to add 25 to this, and I'm just going to write it over here. So we've got 4 times 30 plus 25, and that minor arc is going to be 145 degrees. And that's how you do the clock problem. That looks like a 6. It's a 5. There we go. All right. Last one. Okay, it says write the equation of a circle with 2 y-intercepts. There are rules and whatever to this. I find it's just 10 times easier to just draw yourself a circle that has 2 y-intercepts. It doesn't matter if it has x-intercepts, but it definitely needs to have 2 y-intercepts. So I'm going to put my center here. And I want my intercepts there and there, and that would be 2 y-intercepts. So that would mean that that's going to be the other part of my circle. So the center is at 0, 2, and your radius is 2 because I've gone a distance of 2 one of my directions, okay? So this one's going to be easy. I've got x minus 0 squared plus y minus 2 squared equals 4. If you want to rewrite this a better way, you'd have x squared plus y minus 2 squared equals 4. Now, this is not the only equation of a circle that has 2 y-intercepts. This just happens to be the one that I created. The gist of this is that you just need to draw it on your image first and then write the equation. Don't try to write an equation and check and see if it works, okay? All right, that video is long. I am so sorry, but if you have any other questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in Unit 9. Bye!